Hello, chemists. Hopefully you guys can hear me okay because I'm in the car at dance lessons. Okay, so I promised that I would do some videos with the review, and so I'm going to start with the calculations. Okay, because we didn't spend a ton of time reviewing calculations. I really wanted to get to the booklet, and so let's take a look at those. And so on your test review, you have some calculations here. Number 14, number 15, number 16, and then I'm going to color number 17 and number 18 in a different color because we have two types of calculations. All right, so the yellow ones are our molarity calculations, and then the green ones are the dilution calculations. All right, and we have two different formulas that we're using. All right, we have to use big M for molarity equals mole over liters. All right, so that's the one that we'll always use for the molarity problems. And then for dilution, we use initial molarity times initial volume equals your final molarity times your final volume. All right, so we're going to use that one on those problems. So the first question says, what is the molarity of a solution that contains 4.5 moles of solute in 7.0 liters of solution? All right, so let's break that down a little bit. Molarity just is a way to describe the concentration of a solution. All right, and a solution is not like some mixtures where you have a heterogeneous mixture like cereal in a cereal bowl or even oil and water. Okay, like when we're talking about a solution from a vocabulary perspective, we are talking about something that is a homogeneous mixture. It's the same throughout. Okay, so if you were to see a question about this, you want to remember that a solution is something that's going to mix and everything is going to look the same, inside your solution. It's not going to have chunks in it. Okay, so like if you put sand in water, you've got a mixture of sand and water, but it's a heterogeneous mixture. Okay, it's not a homogeneous mixture because the things in there are different. They kind of stay separated, just like oil and water would, like cereal in a cereal bowl would. So keep in mind that a solution, when you mix these things together, there is no perception that you have that there are different things in there. It kind of just looks the same throughout. All right. So that's what the solution is. All right, so back to the problem. It's saying, what is the molarity of the solution that contains this many moles and this volume of the solution? So again, we're going to use big M equals mole over liter. And so we want to define our variables. So for big M, that's what the question's asking us to find. All right, big M for molarity. And it says that it contains 4.5 moles. So for mole, we're just going to put 4.5 moles. And for liters, we are going to do 7.0 liters. So if we plug this into the equation, the way that our formula is written, it equals x equals 4.5 over 7. All right, so that's pretty straightforward. 4.5 divided by 7 is 0.64. All right, 0.64. It's really 0.6. No. All right, 0.64. And that's our big M for molarity. All right, 0.64. It means that the concentration per liter is 0.64 of a mole of this substance. All right, so the next one says, what is the molarity of a solution that contains, grams? All right, grams. So it says 74.5 grams of barium chloride and 1.5 liters of solution. Well, crud. Grams just means that we have to go that extra step to calculate the molar mass of barium chloride, because the only way that we can get to moles from grams is by using the molar mass. All right, so again, this is our formula. we want to define our variables. So I have big M and then mole and then liters. And then before we get too far into defining those things, we got to find this mole number here because we need moles and we were given grams. And so let's go take a look at the periodic table. I'm looking at my periodic table now and it says barium. We're going to round. So the molar mass of barium is 137.3 according to the periodic table. 137.3 grams per mole for barium. I only have one barium in this compound, so I'm going to stick with that. All right, now we have chlorine, and I have two chlorines, okay, because it's Cl2. So if I have two chlorines, let's go see at the periodic table. It says 35 point, it's really 35.453. So let's round 35.5. But because I have two of them, we need to multiply that by 2. So 35.5 times 2 equals 71 grams per mole. Now we need to add them together. So our 71 plus 137.3 is going to be 208.3. So let's see, we'll just write it over here, 208.3 grams per mole. That is the molar mass of our barium chloride. So now that we have that number, we can do our train tracks, okay? Now, because we almost have no space, I'm actually going to go to the top of the page here to do the train tracks. All right, so we are given 74.5 grams of barium chloride, and the molar mass is 208.3 for 1 mole. Okay, so 208.3 grams for 1 mole. And so now these units cancel out, and we're going to be left with that mole unit, thank goodness, because that's what we need for our molarity formula. And we just do 74.5 times 1, which of course, you don't really have to do that times 1, divided by 208.3, and this is just our mole number, okay? So our mole number, let's use 0.36, okay? 0.36 moles. So all that work just to convert the grams that we were given of barium chloride into moles, but now we are actually working with something here. So it says, what is the molarity? Well, that will be our X then. And for liters, it just, in a very straightforward way, just gives us these liters. And so our X is going to be equal to 0.36 divided by 1.5. All right, so 0.36 divided by 1.5, and that is going to be 0.24 big M for molarity. All right, 0.24 big M for molarity. That means that we have a concentration of 0.24 moles per liter of barium chloride. That is what that means. It is a concentration, it is a measure of concentration in terms of moles. Okay, here we go. We have one more. All right, so it says, how many moles of MgO, magnesium oxide, are dissolved in 1.35 liters of a 2.5 molar solution? All right, so again, it wants to know moles. Now, in the other problems, it was asking for molarity, but now it's giving us the molarity. So again, our formula is big M equals mole over liters. And we have big M, mole, and liters that we need to define. And so the problem's asking how many moles, so that's going to be our X. The volume given is 1.35 liters. And then the molarity is 2.5. So 2.5 big M. Okay, that means we have a 2.5 molar solution, a concentration of 2.5 moles per liter. And so now we just plug it into our formula. So big M is 2.5. And then we have X for where our moles go, and then 1.35. All right, so just don't forget that you guys were rock stars at cross multiplication and division in our gas laws unit. This is no different. So just remember that if you put a 1 right here, then now you have a problem that looks so much more like the ones that you're used to seeing. All right, you're going to just cross multiply these. So it ends up being 1x, which is the same as x, right, equals 2.5 times 1.35. That is it. So 2.5 times, 2.5 times 1.35, and then we get our answer to be 3.375, so we'll just say 3.38 moles. Okay, so that looks good to me. All right, 2 more to go. Here we have, it says, how much of a 12 molar stock solution is needed to make 4.2 liters of a 2.0 molar solution? So we got a different formula now. It's basically saying you have in your stock. The reason it's called stock is because, in chemistry, in labs all over the world, real labs, you're going to have concentrations of chemicals and you're going to need to dilute them. It just makes sense. Okay, it just makes sense that you would, you might go to the store and get cleaner. I don't know if you've ever experienced this, maybe not at your age, but sometimes when you go to buy cleaner, it's concentrated and you'll see on the directions that it says that you mix 1 capful for every gallon or something like that, and it'll have suggestions for times when you might want to make it more strong. Okay, it's the same thing. We have a stock solution, which just means it's concentrated, and in this case it's a 12 molar solution. That's how we say that. It's needed to make a certain volume of a certain concentration of the same solution. And so we know that we're dealing with a dilution. So the first thing that I do with these dilution problems is write my formula. All right, so M1V1 equals M2V2. The trick here is to remember that there are 2 numbers in dilution problems that are describing one solution. Your job is to find that, because if you can remember to keep them together, then all your math is going to work out correctly, even if you misidentify your initial solution for your final solution and vice versa. So here I have these 2 numbers close together over here. So I'm going to read my problem and I'm going to just double check and make sure that they actually do belong to the same solution. And it looks like they do. It says how much of a 12 molar stock solution is needed to make this much, 4.2 liters of a 2 molar solution. So we're talking about the same solution over here. So I want to define my variables. All right, so I have M1, B1, and then M2 and B2. Remember, the 1 just means my initial solution, and the 2 means whatever I'm going to make or what I'm creating or whatever I've diluted, okay? So number 2 usually is the diluted version, and number 1 is usually your concentrated version. So in this case, it's giving us all the information for the diluted version. So it says 4.2 liters down here, and 2.0 mole, or not moles, molarity, okay? Concentration of a 2.0 molar solution, okay? And so on the initial side, and remember, if it's green, or if these things are together, which I've labeled as green, they have to be on the same side of your equation when you write it out, okay? So it has to be the 2's or the 1's, but you can't mix the same solution with the 2's and the 1's. So whenever I plug it in, I'll reiterate that. Okay, so over here, we are still identifying our variables. So this one is 12 molar, and then the volume is what it's asking for. It says, how much do I need? So now let's plug it in, making sure to keep the ones that are together on the same side of the equation. So our M1 is 12, and then we have X. Okay, that looks like a 72. Let's see if I can fix that. 12. And then that equals 2 times 4.2. All right, let's just highlight this in green so you can see. When I said to keep them on the same side of the equation, this is what I mean. We have 4.2 of a 2 molar solution. They have to be on the same side of the equation. Does it have to be on the right side as opposed to the left? Technically, it is supposed to be, but if you were to accidentally flip-flop these, and put the 2 and the 4.2 on the left side instead of the right side, it won't matter. As long as you can solve for x, you're good. So to solve for x, I would say 4.2 times 2 equals 8.4. Let's divide that by 12, and we get 0.7. Oops, 0.7. 0.7 liters, because that is what it's asking us for. It's asking us for the liters, so that's what we did. All right, hopefully you're tracking with me still. The last question here says, if water is added to 1.2 liters of a 25.0 molar stock solution of sodium chloride, and the volume is increased to 4 liters, what is the molarity of the new diluted solution? All right, so again, our formula we're using is M1V1 equals M2V2. We're going to need to identify all these, M1, V1, M2, V2, and then we're going to plug them in. So just like in the problem above, I want to find the ones that are together. What numbers are describing one solution that are close together? This one. Okay, don't get too worried about how it says added. I know it's an important word, but for now, just find the two that go together and figure out if you're going to put them as M1, V1, or are you going to put them as M2, V2. So it says where anytime you see something identified as a stock solution, that's always your initial. Okay, at least in the context of like the examples I've been giving you guys. So we have our volume 1 as 1.2. I'm running out of room, so I'm being a little bit less of a stickler on labeling everything. This one is 25 molar solution. And then my M2 and my V2. So here we go. It says water is added. It doesn't say how much, but it does tell us that the volume is increased to 4 liters. Okay, so our final volume is 4 liters. It doesn't really matter that we figure out like how much was added, because that's not what the question's asking. Now, in some of the practice questions that you had, it was asking that. But in this particular case, it says some amount was added and it increased to this amount, 4 liters. And so our V2 is just 4 liters. So it's not really asking you to do any extra steps. Okay, so our M1 is 25 and our V1 is 1.2. Now keep in mind, I have kept the ones together that I said I was going to keep together. These over here, the ones that are close together in the problem that are describing one solution. And then I'm going to set that equal to the other side, which we have X for the molarity and 4 for the liters. And so I'm going to say 25 times 1.2, that's going to give me 30. All right, so 30 equals 4x. I'm just simplifying the equation a little bit. Whatever's next to the x, that's what we're going to use in terms of division. And so we divide both sides by that 4, which gets the x by itself. And so I divide by 4, and I get 100, and that actually makes no sense. Oh, did I divide by 0.4? Okay, so let's just do that again to make sure I'm not losing it. 25 times 1.2 equals 30, divided by 4, which gets us 7.5. That looks better. X equals 7.5, all right? And it's 7.5 molar solution with big M, all right? All right, that concludes the calculations on the review. So if you were tracking with me, then you're going to do fine. Just remember that when you're given grams and the molarity questions, that you have to find that molar mass, and you will be good to go. All right.